All right. Hello, class, students, parents, anybody else out there watching. This is our Unit 3 practice test review. Hopefully you are going to watch this to completion so you'll be ready for the test on tomorrow.
Good morning, students. This is Mr. Sanchez here also.
All righty. So let's get started here with number 1. There are 15 hats on a rack and 9 of them are orange. What percentage of the hats are not orange? Well, it's important that you notice the question says what percentage are not orange. And let's see, if 9 of them are orange, that means that 6 of them have to be not orange. So 6 are not orange. That's 6 out of, how many total hats are there? 15. So 6 out of 15 are not orange. And another way we can write 6 out of 15 is we can say 6 over 15. Okay, and so if we want to find out what 6 over 15 is, if you remember this in math when we have fractions, well, this is the same thing as dividing. It's 6 divided by 15. So you had access to a calculator here. You can go right to it. 6 over 15 means 6 divided by 15. You can see here that's 0.4. Remember the rule also, we need to multiply times 100. So 0.4 times 100 is actually going to give us 40%. All right, so if you have closed captioning on, then you can see that I've said 40%. All right, so Mr. Sanchez, go ahead, number 2.
Okay, number 2, it says to select all the trips that would take 2 hours. So what you need to do is look at the 3 possible trips here and see if they would take 2 hours to complete. Well, if you look at A, it tells us that you drive 60 miles per hour. Remember that per hour means 1 hour. So you can go 60 miles in 1 hour. And it says between Raleigh and Wilmington, it's 120 miles apart. So you have to figure out how many 160s fit into 120. Well, we know that if we multiply 60 times 2, it will give us 120. So this one right here is one of the trips. So A would be one of them. Let's look at B. This is a walking one. You walk 3 miles per hour to school. So basically this says that in 1 hour per hour, you're going to go 3 miles. Well, which is half a mile away. Well, the school is half a mile away. So if you want to go from 3 miles per hour, you can maybe do like a double number line or a tape diagram to figure out how long it would take you to walk half a mile. Well, why don't we take the per hour and divide it into a half? So divide that by 2. 1 mile divided by 2 is a half. And do the same with the 3. 3 divided by 2 would be 1.5. So this is one it would walk for the 3 miles. It would take wait, I'm sorry, I'm getting confused here.
Well, so if you have to walk a half mile, okay, that's all you have to do. You're walking 3 miles per hour. Is it going to take more than an hour or less than an hour? Well, if you get 3 miles covered in an hour and it's only half a mile away, it's going to be less than an hour. So is that going to be 2 hours? It's not going to be 2 hours, so it's not going to be one of our choices.
So this is not one. Thank you, Mr. Greenwald. Let's take a look at C. So we have a train and it's going 70 miles per hour. So again, this is 70 miles in 1 hour. Well, Hershey to Philadelphia, which is about 140 miles apart, well, how do we go from 70? We can jump from 70 to 140 by multiplying by 2. So this one's going to be a 2-hour trip. This is 100 and so basically here, this would also take 2 hours. So our 2 selections are going to be A and C.
Alrighty. Number 3, Jada's family has completed 30% of a trip. They have traveled 15 miles. How far is the trip? Well, these are problems where it's very important to use either a double number line or a table. All right, so let's go ahead and let's use a table this time. So I have a little table down here that I'm going to drag up. And you guys don't have this convenience, but you can draw one in. But this is for our video since we're making a big video here for the millions of viewers at home. So here's what's important that you need to realize. When they ask us how far is the trip, you need to realize that they're talking about the whole trip. So the whole trip is 100%. So I'm going to go in here and I'm going to say, okay, 100% of the trip Okay, we should also, I should mention, we should also label the sections here. Let's go ahead and look at what we have. We have a percentage and we have miles. So let me change my color here to orange. We have percentage and we have miles. So I'm going to label both percentage and miles here. And that there. Okay, so percentage and miles. The whole trip is 100%. Okay, and let's see here. We want to find out how far the trip is. Well, we know this much right now. We know that they've gone 15 miles. So we can fill in 15 miles. And we know that that is 30% of a trip. So we can come in here and say, okay, this is 30% of the trip. So we want to talk about going from 30% of the trip, which we know about, to 100%, which we don't yet know about. Well, it can be difficult to figure out what to multiply by to go from 30 to 100. Okay, so what we may want to do, what may help us here, is to think about what 10% of the trip would do. And I say 10% because 10% is easy to find, and it's also going to be easy to get back to 100. So let's fill in a value here for 10% first, and then we can come back. So 10%, okay, is going to be, you're going to have to take the 30% that we know about and divide it by what? 30% divided by 3, right? So 15 miles also divided by 3. So we want to take this, this is going to be divide by 3, and this is going to be the same thing. It's going to be divide by 3. So divide by 3, and so 15 divided by 3, that is 5. Okay, so we know that 10% of the trip is 5 miles, but we want to get back up to 100%. So let's see, how do we make the jump from 10% up to 100%? Well, it's going to be times 10, right? So we're going to do the same thing here. We're going to do times 10 here. So 5 times 10, that is 50. All right? So the trip is 50 miles long. All right? And Mr. Sanchez.
Okay, for number 4, it says that May runs 3 laps around the track in 4 minutes. So in this problem here, we're comparing laps to minutes. So the 3 questions are, how many minutes per lap is that? How many laps per minute is that? And if Maya runs 21 laps, how long does it take her to complete that? Well, I think the best thing for this one to use is a double number line. So if you go down here, you can take one of these and drag it up. Let's see. You can leave it here for now.
All right.
Okay, so let's take a look. So we're comparing laps to minutes. So you want to label what these number lines show. So I'm going to put in here an L for lap and M for minutes. And it's telling us up here that 3 laps in 4 minutes. So I can I'm going to make this number 1, 2, 3. I'll make this a 3. 3 laps and 4 minutes. So the first question is, how many minutes per lap is that? Well, per lap, per means 1. So I want to find in 1 lap, how long will it take? Well, we're going from 3 to 1. How do we do that? Well, we divide by 3. So if I take 4 divided by 3, there's a different ways I can do this. I can write this as a fraction or as a decimal. It can be 4 over 3, 4 over 3, or I could divide. You could use your calculator here. 4 divided by 3 would give you, it's a repeating decimal, 1.3. I'm going to put an extra 3 there. So a little bit more than a minute, 1 minute and 33 hundredths of a minute. So that would be for A. Let's take a look at B. Now B is a little bit different. It says how many laps per minute? Well, per means 1, so we want to make 1 minute. So let's put in here 1 minute. Right here. I'm going to make this here 1 minute. And then we have to figure out, well, how do you jump from 4 to a 1? Well, this time you divide by 4. So I'm going to divide 3 by 4. And you can write a couple of different ways. You could say 3 over 4, 3/4, or you could convert it into a decimal. Well, 3 divided by 4, if you plug it into your computer or calculator, it would be 0.75 think of 3 out of 4 quarters, 3/4, same as 75 cents. So this answer would be 75 hundredths. This is a 7 right here. Okay, so that would be for B. So let's take a look at C. Now C is actually the easiest one because we want to, it says if my runs 21 laps at the same rate, how long does it take her? So we're looking at laps at C, and it looks like we're going to go from 3, you can go to 21. So I'll make this over here, 21 laps.
Remember, they told us in the very beginning that they go 3 laps in 4 minutes. So we want to go from the 3 laps we know about up to 21 laps and see how many minutes that is.
So then we go from 3, we can jump to 21. Well, by multiplying by 7, we'll do that with the minutes. 4 times 7 would give you 28. So it would take 28 minutes to go 21 laps. Perfect, class.
Alrighty, so looking at number 5, a sailboat captain is mapping a trip and wants to know the distance the sailboat will travel over certain time intervals. Assuming that the sailboat travels at a constant speed, what is its speed? Well, it's important to remember that speed is talking about amount of distance you cover in a certain amount of time. So we're talking about, it can be miles per hour a lot, but it can also be different units as well. But so in this case here we have time in hours and distance in miles. So you can see here, look at what's happening in the chart. 0.5 hours go by, it goes 7.5 miles in half of an hour. Well, then if we jump up to 1 hour, how much more time has gone by? Well, to go from half of an hour to an hour, that's another half of an hour. So it's going to be another 7.5 miles. So 7.5 and 7.5, you can add those up, or you can do 7.5 times 2. Either way, you're going to get 15 miles. And you can verify that that's true because if we go another half hour to 1.5 hours, and you add on 7.5 miles to 15, it's going to be 22.5. So 15 miles is what we're looking at here. All right, number 6.
Okay, so here we have a pumpkin problem. It says, which one weighs more, a pumpkin that weighs 6.5 kilograms or a baby that weighs 10 pounds? Ooh, that's a big baby. So it tells us here, down below, that 1 pound is about 45 hundredths of a kilogram. Well, since the pumpkin is already in kilograms, let's convert the baby's weight, pounds, into kilograms as well. Well, we know that 1 pound is the same as 45 hundredths of a kilogram. So if we have 10, well, class, how do we jump from 1 to 10? You multiply by 10. So that means we multiply 45 hundredths by 10 as well. So if you put it into your calculator, you would end up with 4.5 kilograms. And now we can compare the two weights and see which one weighs more. Well, a pumpkin is 6.5 kilograms. A baby is 4.5 kilograms. So the pumpkin is the one that weighs the most.
All right. All right, so here we have Andre and Lynn. They are 12 miles apart on a path when they start moving towards each other. Andre runs at a constant speed of 5 miles per hour, and Lynn walks at a constant speed of 3 miles per hour. How long does it take them to meet? Well, these are ones where I think if you have just a little basic diagram, it may help you to kind of see what's happening. So you can imagine, let's say that we have 2 people, and they're apart from each other, and they're going to be moving towards each other. So I can literally just draw little basic dots here, and we can see these are the people, right? We can say Andre and Lynn. I'll just put A and L here. Okay. Andre goes 5 miles per hour. Okay, and Lynn walks 3 miles per hour. Okay, they're coming towards each other, right? Lynn's going sort of this way, Andre's going this way. They're coming towards each other. How long does it take them to meet? Well, what is their rate of speed here? How much ground are they covering? This one is difficult or tricky, possibly, because they're coming towards each other. So that means that if Andre is going 5 miles and Lynn's going 3 miles per hour, they're actually covering 8 miles in an hour because they're going in the same direction. So it's like they're kind of working together to cover this distance between them. So they cover 8 miles in an hour, but they need to cover 12 miles to meet each other up. So they need another 4 miles. Well, if I think about it, 4, that's half of the 8. So if they get 8 miles in an hour, we need another half of an hour for them to get those 4 miles. So it'll be an hour and a half. All right.
Okay, number 8. A Lamborghini traveled 220 miles in 4 hours. How many miles does it go per hour? So remember, class, that per means for one. Well, there's different ways you can do this. One way is you can just divide and break up the 4 hours into one. So that means you divide by 4. So 220 divided by 4 would give you 55 miles per hour. Or you can actually do a table, which I'm going to kind of show you with the table, and work it out this way. So let me bring up my table here. Okay, here we go. So let's give it, let's title our two columns here. So the first one I'll put will be miles, and the other one will be hours.
Definitely important that you decide what's going to go there right away, because that's going to make everything fit in nicely for you.
That is true. So if we look at the problem, it tells us 220 miles in 4 hours. So I can come and drop these off in here. So let's see, 220 miles in 4 hours. Okay. But we want to know is how far does it travel in 1 hour? Well, this should be pretty easy. So let me just pencil this in here. We want to go to 1. Well, how do we go from 4 to 1? Well, we divide by 4. So we do the same with this 220. 220 divided by 4 would give me 55. So our answer is right here. It tells us that this for Lamborghini goes 55 miles in 1 hour.
All right. All right, so these questions down here are maybe a little bit different format than what you're used to, but it's covering the same kind of things that we've been talking about. So enter the unknown value that makes the statement true. 100% of blank is 80. Well, if we know it's 100%, that means it's the whole thing. So if 100% is 80, well then we have to be talking about 80. So it has to be 80. All right. So if you understand what 100% means, that one was really, really easy. All right. Next one.
Okay. So here's another one like the previous one. So we're looking for some number, and it tells us it is 30% of 80. So right there, it tells me I need to figure out what is 30% of 80. Well, you can probably convert 30% into a decimal, which would be 30 hundredths, 30 out of 100. And we can multiply by 80. And once we multiply 80, well, remember some of the shortcuts that we learned. First, multiply, you can kind of figure that 3 times 8 is going to give me 24. So we get this in there, 24. And then we have a 0. Actually, we have a couple of zeros. And then we have to account for the decimal. Well, we have two numbers behind the decimal. So you slide over 1, 2 places. And 24, you can just get rid of the 2 extra zeros at the end, so it would be 24. So 30% of 80 would be 24.
All right. So for this next one here, we have Brett. He's coloring in 20% of the total shapes on his paper. And he colors 8 shapes. So 8 shapes is 20% in this case. That's what he colors. 8 shapes is 20%. So enter the number of shapes on Brett's paper. Well, okay. So in this case here, if you remember in the previous problem, I should say that 80 was 100%, and then we wanted to find out what 30% is. And so you could have thought 10% of 80 is 8. And then so 30% is going to be 3 times that. So 3 times 8 is 24. Well, down here, we don't know what 100% is, right? We know what 20% is, though. We want to figure out the number of shapes on Brett's paper. This was the total number of shapes, so I don't know if that was clear or not. But if we want to find out the total, that means we want to find out 100%. If we know 20%, how can we jump from 20% to 100%? Well, you just do 20 times 5, and that'll give you 100%. So then we've got to do this one times 5. 8 times 5 is 40. All right, so you could have used a double number line or table, but some of them you can kind of do in your head a little bit as well. All right.
So the next problem is very similar to the one we just finished doing about Brett. So you can do it mentally, but I'm going to do this one with a double number line. So it tells us that enter the unknown value that makes the statement true. 25% of what number is 20? So if you take 25% of this mystery number, you get 20. So if I come in here and do real quick, we just might make a double number line. And we want to make sure that we label them so we know what these numbers represent. So we can have here this is the percent, and the second one will be the number. So we know that we have 25%. So let's put it right here, 25%. And we're going to make that 25% is 20. So what we want to know is what is the whole number, the entire number? Well, that would be 100%. So I'll slide this over here, put it towards the end. And there's a whole bunch of numbers we can probably figure in between them that we really don't need. So you have to figure, how do you jump from 25 to 100? Well, you multiply by 4. So do the same to the bottom. 20 times 4. Well, 4 times 2 is 8, and you have a 0. So that mystery number would be 80. So 25% of 80 right here would be 20.
All right, thank you, Mr. Sanchez. All right, let's look at slide 2, or page 2. All right, number 9 says the table below shows how much money Addison earned shoveling snow for a different number of driveways. Okay, so we look here, we can see driveway shoveled, amount earned. Okay, at this rate, how much would Addison earn if she shoveled 11 driveways? Well, let's look at it, see what's happening here. Let's notice some patterns here. On the shoveled side, it's going 3, 5, 7, 9, right? It's every other number, right? It's going, it's the odd numbers, you could say, right? So what would the next number be here if we're going odd numbers? 3, 5, 7, 9? Oh, it would be 11, right? So let's see what's happening over here in this side. In this side here, from 33 to 55, that is increasing by 22, okay? 55 to 77, it's increasing by 22 again. 77 to 99, increasing by 22 again. So we're increasing by 22. So if we increase 99 by 22, that's going to be 99 plus 22. All right, so let's see here. 99 plus 22. I noticed that for a lot of you, I think you added 11. A lot of people added 11 instead of 22, and that's why you got it wrong. If you had 9 plus 2, that's 11. All right, and then 10, 12. So 121 would be the amount of money that Addison would have earned. All right.
Okay, for number 10, we have 3 tickets were bought for the corn maze, and those 3 tickets were $54. So 3 tickets for $54. So what we want to know is at this same rate, what is the cost of 2 tickets? Well, let's break it up, and how much would it be for just 1 ticket? Well, we can divide this by 3, and we get 1 for 1 ticket, and 54 divided by 3 would be 18. So basically, it's $18 per ticket, but that's not what we want to answer. We want to know is how much is it for 2 tickets? Well, we can double it. So multiply it by 2. Doubling means you can multiply by 2, or you can add it to itself. So 18 and 18 would give us $36. So it would be $36 for the 2 tickets for the corn maze.
All right. And so these little pictures here, I'm covering up some questions that I decided we didn't need. The area for a rectangle or triangle, you can see there. Hopefully you didn't forget. All right, number 13. Diego is making a punch that requires 8 cups of orange juice, but the store only sells orange juice in pints. How many pints of orange juice will he need to buy? And they remind us that 1 pint equals 2 cups. Well, so 1 pint's 2 cups, but he needs 8 cups. Okay, so we need to make 2 cups become 8 cups. So we need 2 times 4, right? And as it turns out, that means the pints times 4 as well. So 1 pint, we're going to need 4 pints, since that gives us 8 cups. All right, 4 pints, because we need 8 cups. All right.
Number 14, we're looking at the table, and we're going to answer the following question. Well, we notice that these are cupcake toppings, and it tells us the total. So our 2 columns, we know what they represent. But the question is, what percent of the cupcake toppings are chocolate sprinkles? Well, We're looking for a percent, Well, we know that percent means out of 100. Well, first, let me add all these totals and see what that gives me. Well, if I add 30 plus 15, 45, plus 10, 55, plus 20, 75, and 25 more is 100. Oh, this is very good. This right here tells us this is 100. So this will be like out of 100. This could be my percent. And it says what percent of them are chocolate sprinkles. So here we have chocolate sprinkles. So it's 20 out of 100. Well, because this already has 100 below, we don't have to worry about making it into 100 because it already is 100. So 20 out of 100 would be 20% of them are chocolate sprinkles.
All right. All right, number 15. A school has 100 students. On Friday, 70 students went on a field trip. What percentage of the students did not go on the field trip? Well, how many students did not go on the field trip? If 70 students went on the field trip, how many left over are there in the whole school if it has 100 students? That would be 30, right? And so just as we saw in the last problem, things are very convenient. Since it's already out of 100, it's going to be 30 out of 100. And 30 out of 100, as you just saw, that's 30%. 30%. All right, number 16.
Okay, number 16. So we have 3 students, and it says Madeline has completed 10 of the 20 problems. So right there, I know how long this homework assignment is. It's 20 problems, and she's done 10. But Will has completed 80% of the problems. Again, we know it's 20 problems, and he's completed 80%. And Adam has finished 3/4 of them. Who has finished the most? Well, we're all going to have to write them in as the same unit so we can compare them. Well, I see that Will already has 80%. So I think I'm going to make them all into percents. So Will has 80%, and then we have Adam, he has 3/4. Well, 3/4 kind of reminds you of like quarters, like 3 out of 4 quarters would be 75 cents, which would be 75%. So I'm going to put this here for Will. So he's completed 75%. And let me take a look at Madeline. She has completed 10 out of 20. Well, 10 out of 20 is half of the problems. Well, 1/2 is the same as 50%. So now this makes it really easy to see who's done more homework. So who has finished the most? Well, Madeline has finished 50%, Will 80%, and Adam 75%. So it would have to be Will. He's finished the most, 80%.
All right, very good. Number 17, in a bag of Starbursts, 30% of the bag are pink. Okay, it does help to know that the Starburst bag normally comes with different colors, right? The pinks, those are my favorite, but there's yellow and there's red and orange. I think maybe purple as well. Anyway, there's a bunch of different colors, and 30% of this bag are pink. There are 90 pink Starbursts in the bag. So how many Starbursts are in the bag? Okay, this again, they must mean how many total Starbursts, right? With all the colors all combined. Well, this is one where it might help you to see, let's say, a double number line. So let me get a double number line here and drag it up. Whoop, it's not dragging. I'll have to make my own here. I'll have to be like everybody else here and create one here with the straight lines. And so we know then that if 30% are pink, okay, 30% are pink and 90 are pink, then those go together, right? So we can say then that we have the percent and then the number. So again, percent and number. Those are the things we're considering here. So this is like the pound sign for numbers. So 30 and 90, they are aligned. 30 and 90. We want to find out how many total are in the bag. So that means we want to find out about 100%, right? So down here somewhere is going to be 100%. How do we go from 30 to 100? Well, that may be a little bit tricky. So maybe let's go ahead and let's see if we can find out what 10% might be. So to go from 10 to 10%, we're going to be dividing by 3, right? So divide by 3 and then divide 90 by 3, and that's going to give us 30. All right, so 10% is 30. So how much would a 100% be? We're going to go from 10 to 100. So to go from 10 to 100, we're going to multiply times 10, right? So it's going to be the same thing here. We're going to do 30 times 10. We're going to add a 0 on the end. It's going to be 300. All right, great.
Okay, so we have a teacher, Miss Goswami, and she's 64 inches tall. About how many feet tall is she? Well, it doesn't ask for an exact amount. It says about how many feet. So if you take a look here, we know that 1 foot is the same as 12 inches. So right now we have 64 inches tall. So we can take 64 and divide it by 12. So 64 divided by 12. And if you work this out, it's going to give you 5 feet, but you have a remainder of 4. So that means 5 feet, 4 inches. These two little hash marks mean inches. The 1 means feet. So 5 feet, 4 inches. Well, about how many feet tall? Well, that's closer to 5 feet. So she's about 5 feet tall.
All right, and last one down here. Clark biked 4 miles in 20 minutes. How far can he go in 2 hours if he bikes at this rate? Okay, so down below here they mentioned that we can use either the table or an equation. Now, we haven't taught you guys how to make an equation yet for this. That's going to be happening after winter break. But just be aware that you are going to be learning that after winter break. But we do know about tables, right? We do know about tables here. And so we have minutes and hours, okay? And so if we look at it here, minutes, miles, and hours, I should say. We have all those things in here. So we can fill this in. This table is a little bit of a tight squeeze. That might be tough to write in there. Let's think about this here. Clark bikes 4 miles in 20 minutes. How far can he go in 2 hours? Well, how far can he go in 1 hour? Okay, if it's 4 miles in 20 minutes, this is where you have to be careful. It's not 4 miles an hour. It's 4 miles in 20 minutes. How many 20-minute segments are in an hour? 20 times 3. Right? So that means in an hour, Clark's actually covering 12 miles in an hour. So if he's covering 12 miles in an hour, how far can he go in 2 hours? Well, it's going to be 12 times 2. He's going to be able to go 24 miles. Okay, so this one was kind of a bonus question. You can see here there's no green box for you to fill in, so it was just a bonus question. But that's how you would do it. Alrighty, hope this helps.